Hello and welcome back to Arduino for Amateurs. This is episode number 12, IR Remotes 2. We're going to be talking about IR remotes. We're also going to be integrating them with our NeoPixel rings that we talked about a couple episodes back. So as always, my name is Matt Gracie. I'm a hacker from Buffalo, New York. I'm a member of the Bithaven Hackerspace. And today we're going to be doing sort of a live coding exercise combining two things that we've already talked about, infrared remotes and NeoPixel rings. Basically, we're going to write a program that allows us to change the color of a NeoPixel ring using the buttons on an infrared remote. So sort of combining two episodes that we've had in the recent past. This is the remote that we're going to be using. I've got it right here. This is the remote that I use to control the lights here in my home office. No particular reason I chose this remote. It just happened to be one that was handy. You'll see remotes like this pretty commonly with a lot of embedded systems and cheap strip lights and stuff, which is what I've got in here. What we're going to do is we are going to write a program that uses these top row of buttons here, the red, green, blue, white, to change the color of a NeoPixel ring. NeoPixel rings, just to refresh your memory, are devices like this. Each of these little white boxes contains an LED along with a control chip. So each of these lights is individually addressable in software. There's 16 of them. I can set them to blink or run or do different colors. I can do whatever I want in terms of display with them. And these same principles that we're talking about with the NeoPixel rings work with any other WS2812 compatible lighting accessory. So, for example, I have a strand of Christmas lights. 50 lights operate the exact same way. Each light has a chip in it. Each one is individually addressable. I can program them all off an Arduino. So the stuff that I'm showing you with this simple example, also applicable to much larger lighting installations. So this is the front of the NeoPixel ring. This is where the LEDs are. On the back, we see we've got 6 through holes. We have 2 for ground, we have 2 for power, and we have 2 for data. One is marked data in, one is marked data out, so that you can daisy chain these together and programmatically control them all with a single wire. I haven't had any luck doing that myself. I'll give it another try soon. I haven't gotten back to that since I recorded the first video. This is the circuit that we're going to be working with today. So it's a pretty simple one. We've got our Arduino up here in the corner, of course. Down here, this is our infrared receiver. So if you recall from the last video, the infrared receiver has 3 pins on the bottom of it. One for ground, which we see is connected here to the ground rail. One for power, which is the red wire connected here to the power rail. And then one for output. So that is this greenish blue wire that's connected up here to pin number 7 on our Arduino, digital input pin 7. Over here we have our NeoPixel ring. So power is connected here to the power rail, ground is connected here to the ground rail, and then that DI, the data in through hole, is connected right here, and then that yellow goes back here to pin number 4 on our Arduino. We also have a potentiometer over here. That is hooked up and it's powered and it's connected to pin analog 0, the analog input. Probably not going to use that in this video, but it was part of the circuit that I already built, so it's still in the picture. And then we see we've got a 5-volt connection here coming from our Arduino. That is right up here, powering this rail. So that's where the power for the infrared receiver, the power for the NeoPixel ring are coming from. And then same thing with the ground. We have a ground connection here. It's going back to ground on our Arduino. So we're going to power this whole thing via USB when we connect it to the computer I'm using to record this. And then that 5 volts is going to go into the rail, and then all of this stuff will be powered. Okay, so we're going to combine the functionality of 2 programs that we wrote in earlier episodes in order to make this project work, in order to make this NeoPixel ring settable via our infrared remote. So I've got my first program here, the Simple Remote Colors program. You probably remember this from the last episode. And what this does is it decodes the input from our infrared remote, and then prints to the serial monitor what color I pushed. So red, green, blue, white, right? So we're going to start with this. So I'll highlight all of this, copy it, Control N to open a new sketch. Put that up on the screen here. Control A and V. So just a brief refresher to go over the code. First, we include our IR remote library. If you recall from the last episode, I installed IR remote library version 2.6. That's still what I'm using on this computer. We have a constant, so we set the integer receiver pin to 7. Then we set up a IR receiver object connected to pin 7, so IR receiver receive pin. We have a results data structure of type decode results. And then we have this unsigned long called key value. So that's just a long 32-bit unsigned integer. In setup, we start our serial monitor. You know what? We're not going to need that today, I don't think, so I'm going to go ahead and delete that. We tell our IR receiver to enable infrared in, that is, start listening for incoming infrared connections. And then we turn on blink 13. So that is the function that blinks the LED on our Arduino when it receives an IR signal, right? So we can make sure that that layer 1, that physical layer, is working properly. It's seeing the signal. My remote's not out of batteries. You know, there's not interference from some other IR radiation in the room. Everything is doing what it's supposed to do. Then we get into the loop here, and the loop is very simple. We basically just, if there are results to decode, we print what they are to the screen, red or green or blue or white, right? And then we continue looping because that is how Arduino sketches work. We go back to the top once we get to the bottom. All right, so that is the IR piece. Now we need to marry that to the NeoPixel code. Again, this is code that we used in an earlier session. It was just called NeoPixel Ring. I'm going to go ahead and delete the comments because they're really not super applicable right now. All right, so at the top, I will copy this part into our new sketch. I'll do it here under the ones from the infrared code. So we are including the Adafruit NeoPixel library, again, already loaded in this Arduino. If you needed to load that, you can do it here through the little book icon that opens up the libraries. We're going to define a pin 4. That's the pin that our NeoPixel ring is connected to. We're going to define number of pixels, 16. So there are 16 LEDs on our NeoPixel ring. And then we are creating an Adafruit NeoPixel object called pixels with those characteristics. So 16 LEDs connected to pin 4. Here's how we're encoding the color data. All right, so that is the beginning of that. Now, what do we need for setup? Go back here. Okay, that's the remote one. Want the NeoPixel one. Copy all this. Put it in our new sketch. All right, so we initialize the NeoPixel ring. We will set the brightness to 20. We will clear any data that is buffered in those LEDs, any leftover static values or whatever, and then show. So basically, turn on the ring, verify that everything is blank. Okay. So by the time we get to the end of this combined setup, our infrared receiver should be ready to go because we've done all the instantiation for that, and our ring should be ready to go. So we've got all of that. All right. And then let's take a look at our code for our NeoPixel ring here. So I'm going to copy this whole loop function. I'll put it over here, and I'm going to put it after the loop that we already have, and I will explain why in a moment. So at this point, we need to make sort of a decision about the structure of our program, right? The loop that I just copied over from the NeoPixel program does a very simple for loop So it loops through all of the LEDs. It sets the color for each of them to, in this case, 000, so it's setting them to blank. Then it updates the ring, then it waits. Okay? I'll delete these lines because we don't really need them right now. So we have two options. One is we can write this for loop and add it to each case in this switch statement. So if the case is FF1AE5, which we know is the red button, then run the for loop and set the pixel colors to red. If the case is FF9A65, do it and set it to green, and so on. Basically put a for loop in each of these cases. But that's kind of duplicative, right? We're doing the exact same thing. The only difference is we're setting the value a little bit differently, right? In every single case, we're iterating through every LED in the ring. We just need to have some way to do that and pass in a color. So what we're going to do is we're going to turn this into a separate function. All of the code that we've looked at so far has had two functions. It's had setup and loop. But in an Arduino sketch, if you have code that you're going to reuse, if you're going to have to do the same thing in multiple contexts, it's best to break that out into its own function, and then you can call it again and again and again, right? It becomes sort of just a black box you can pass stuff into. So instead of loop, we will call this change color. And we need some way to pass in the color that we're changing it to. So if you look here, this pixels.color routine. Oh, I think I got to do a verify here. For whatever reason, it just does not seem to like giving me the syntax highlighting until I've done a verify. If we look here, what this color method returns is an unsigned 32-bit integer, a long. And it takes 3 8-bit integers, right? So 3 regular integers go in, 1 32-bit integer goes out. So for this change color, we will just pass in that 32-bit integer. So we'll say long and then import color, because that's the color value that we are importing into this function. Okay. And then we use the same for loop, and we just tell it, instead of this, we will just use import color. Okay, and then that is about it. And then we just need to update this to call that function. So we'll call the function change color, and we will call it with pixels.color 25500, because we're using red, green, blue. So it's 255 for red, 0 for green, 0 for blue. This will give us red. And let's duplicate that on these other 3 with the appropriate colors. And then we will trace through it again, just to make sure we're all on the same page before I push this out to the Arduino, and hopefully it works. Again, kind of doing this without a net. I don't have a printout or anything, but I think I'm on the right track. All right, and then for this last one, white, that would be 255.255.255. So 255.255.255 is white, this is blue, this is green, this is red. So what happens when we hit the button? Well, we hit a button on our remote, right? The infrared LED on our remote produces a modulated signal. You know, as we discussed in the last episode, it's kind of like Morse code. It encodes a digital value into a rapidly blinking infrared light. The receiver receives that, decodes it, turns it back into an electrical digital signal, an electrical binary value, and then puts that in this results.value variable, right? So results is the data structure that contains it. Results.value is taking those results, turning it into a hex value. And then it compares it in this switch statement against these cases. So if the encoded value is the hexadecimal value FF1AE5, what we're going to do is we are going to call this change color function. That's what's happening here. And the argument that we were passing in, the value that we are passing in, is a long, that is a 32-bit unsigned integer. And the value is generated by this color function. So we are feeding in 25500. It is going to turn that into, as it says here, a single packed 32-bit RGB color. So it's going to turn that into a single long integer value. That value will be assigned the name import color. And then just like in our old NeoPixel ring code, this for loop goes through the entire inventory of LEDs from 0 up to 15. And sets them all to import color. So it sets 0, it sets 1, it sets 2, it sets 3. Once it gets to 15, it sets the value of that to import color. And then it updates the ring and shows. Okay? So what should happen is we should hit the red button. It'll generate the appropriate long value. The long value will go into change color. The for loop will execute, and our NeoPixel ring will light up red. That's what should happen. So let me verify here, just to make sure I didn't miss any semicolons or anything. Nope. It says here our sketch is using 25% of our program storage space, so it's probably a good thing that we're learning about functions so that we're not writing duplicative code and taking up memory for no good reason. All right, and it'll be interesting to see how I hold this. So I have plugged in my ring. I will upload. And if I hold this up here, you'll see, make sure it's on the camera, I've got my infrared receiver here, my NeoPixel here. If I hit red, there we go. Wasn't hitting dead on, I guess. If I hit green, if I hit blue, and if I hit white. All right. So we have successfully integrated an infrared remote with a NeoPixel ring. We hit the buttons on the remote. The ring does what we want. It changes it to the color specified on the button. Now, as I mentioned in the last video, there's no requirement that the code that executes when it gets a signal matches what's on the button. That's something that we did for ease of use, right? You can have it do whatever you want. We could assign functions to it using this remote instead if we wanted. This doesn't even have color buttons on it, but we can change the patterns. We can do all kinds of stuff with that NeoPixel ring or that string of Christmas lights or whatever output device you like, right? Our point here is that we're using the code on the Arduino to glue together input from an infrared remote and digital output to an output device like a NeoPixel ring. So this is just kind of foundational, logic that we're using to glue together inputs and outputs and make it do cool stuff, right? And that's really the fun of Arduinos. All right, I hope you enjoyed this. If you want the code, let me know. I'll put it up on GitHub or something. Otherwise, I will see you in the next episode. I think we're going to talk about IR transmitters. So in addition to receiving IR signals, an Arduino can be programmed to generate them as well. So I'm going to figure out a way to programmatically mess with the lights here in my home office. Sounds neat. I'll see you there.